Hi friends, today we will see the equivalent circuit of induction motor. So in the last video we have already seen the current flowing in the rotor um, of an induction motor is equal to S into E2 divided by square root of R2 square plus Sx2 whole square. Okay, so this equation can be modified like this. So e2 by square root of r2 by s whole square plus x2 square, right? So you can modify the equation like this. So from this equation, okay, so you can draw the circuit diagram. So this is the impedance and this is the voltage. So this is the current flowing through the circuit. So this will be the R2 by S resistance, and this is the reactance and X2. Okay, so this is the circuit. Okay, so this is E2 is the voltage given and the current flowing is IR. So R2 by S is a variable because S is there. Your speed varies, S varies. So R2 by S is a variable. So now let us write R2 by S is equal to R2 plus R2 into 1 by S minus 1. Okay, can we write like this, right? So R2 and R2 will be cancelled, R2 by S will remain. So this R2, this part belongs to the rotor copper loss, and this part belongs to the mechanical power developed. Okay, so you can replace R2 by S. So in this circuit like this, so this is only R2, okay, where the copper loss will occur, rotor copper loss will occur, and this is the reactance X2, okay, and this is the corresponding to the load. Okay, so this is a variable, so that's why I have drawn a variable resistor. So 1 by S minus 1. So this is E2, okay, and this is IR. Okay, so this is the equivalent circuit of the rotor. Okay, so this is all equations coming are for rotor. So this is the equivalent circuit of the rotor. Now let us draw the equivalent circuit of the full induction motor. Okay, equivalent circuit of induction motor. Okay, so equivalent circuit of induction motor is similar to the transformer. Okay, because the principle is same and the primary is equivalent to the stator. Primary of the transformer is equivalent to the stator of the induction motor, and secondary is equivalent to the rotor of the induction motor. Okay, so the principle is also mutual induction. So the equivalent circuit of induction motor is equal to the equivalent circuit of the transformer. Okay, so this is a stator resistance and this is a stator inductance, stator reactance, and there is a shunt branch parameters also. So this is the core loss component and this is a exciting component. So this is R0 and this is X0. Okay, and so this one is the rotor equivalent circuit. Now this is on secondary, right? This is rotor, so it is a secondary side. So I am taking these all the parameters to the primary side. Okay, so I am taking all the parameters to the primary side. So this becomes R2 dash and this will be X2 dash. Okay, so like that. So this will be R2 dash and this will be X2 dash, right? So R2 dash is equal to R2 by K square, right? So if you bring the components of resistance and reactance from secondary to primary, so those will be divided by K square. Understand? So that is equal to X2 by K square. And load component of resistance. So this is the electrical equivalent of mechanical load. Okay, so this is the electrical equivalent of mechanical load. Okay, so this will be R2 dash into 1 by S minus 1. So it is nothing but RL dash. So if you consider this is a load RL, then it will be RL dash. So that is equal to by K square. Okay, understand? Okay, R2 into 1 by S minus 1 divided by K square. Okay, so this is E2. So if you come to this side, then it will be E2 dash. So that will be equal to E1. Okay, so here this is voltage given to the stator V1 and this is a current I1. Okay, so this is similar to the equivalent circuit of the transformer. Okay, so in transformer the no load current I0. Okay, so the no load current I0 is very small. Okay, it is nearly 5 to 6% of the full load current. So if you neglect the shunt branch parameters in the transformer, so there is no much change in the parameters, okay, of the circuit. But in the induction motor, this no load current is not that much less. It is nearly 30 to 50% of the full load current. In induction motor, this no load current I0 is 30 to 50% of the full load current. So you cannot neglect these shunt branch parameters. Understand? You cannot neglect these shunt branch parameters. Okay. So so this is component R0 is corresponding to core loss. Okay, so in normal operating condition, so core loss is almost constant and is very small value, so we can neglect this core loss, okay, while drawing the equivalent circuit. But for calculating the parameter values like torque and speed, so other parameters, while calculating those things you have to consider this also. Okay, but for equivalent diagram purpose we can neglect this. Okay, so finally you can draw the equivalent circuit of the induction motor like this, x1. So by neglecting R0 core loss component you can neglect, but you cannot neglect this one, x0 you cannot neglect. Okay, so because the I0 is larger, that means 30 to 50% of the full load current. Okay, so this is R2 dash and this is x2 dash. So this is the load. So this is V1 and this is I1. Okay, so this is the final equivalent circuit of the induction motor. Okay, thank you.